Lesson 0.3 is on calculating averages. And in sports, there are different ways that we use the word average. But in general, it usually means that we are calculating some value that is between the lowest and the highest value in a series or of scores or numbers. In the world of statistics, there are a couple of different types of words that refer to an average, and we're going to use those terms to be a little bit more specific. One of those is the term mean. And we have a symbol in statistics for mean, which is this one right here, and we call that the X bar symbol. The mean is what we typically think of when we say average. And to get a mean, you add a list of individual scores and then divide by the number of scores that are in the list. For example, if you have taken 5 tests and you've earned scores of 91, 79, 86, 79, and 73, you can calculate your mean test score, which would be X bar, by adding the 5 scores together that you earned and dividing by 5. That would give you a mean score of 81.6. Example number 2, what score would you have to get on the next test in order to have a new mean test score of 85? In this one, we're going to set up an algebra equation to solve for our missing test score. So with the 5 tests that we know, which are given in example number 1, plus the 1 score we don't know, we're going to write that as 91 plus 79 plus 86 plus 79 plus 73 plus X. When we were calculating the mean of these scores, we now have 6 scores that we're averaging together. So I would divide that sum by 6 this time, and I want my mean score to work out to be 85. Now, the easiest way to solve this is to clear out that denominator in this fraction, and the way I'm going to do that is by multiplying both sides of the equation by 6. So let's play over here by 6. All that's going to do on the left is cancel out this denominator, and on the right, I can actually multiply 85 times 6. The other thing that I can do is I can add together the 5 test scores that I know. So the 5 test scores that I know add up to 408. 85 times 6 gives me 510. And now I have a simple one-step equation to solve, and I can just subtract 408 from both sides, and that tells me that my next score has to be 102. Now, another way that we sometimes calculate an average or a typical value is by finding the median. And the median is a middle score. To find the middle score, you must first be sure that all of your scores are arranged in order from smallest to largest. So in example 3, they're asking us to find the median of the 5 test scores given in example 1. I'm going to rewrite those 5 test scores in order. Notice those 5 scores are now listed from smallest to largest. And when we have an odd number of scores, we can find the mean simply by looking for the middle number. So the middle number in this case is the 79, because I have 2 scores below it and 2 scores above it. So my median score would be 79. Now in example 4, it says, suppose that the next test score is 94. What would the new median be? Again, I'm going to list all 6 scores, including the new score of the 94. And this time, because I have an even number of scores, there isn't a middle number. The middle would be exactly halfway between these 2 scores right here. And I apologize for the messy handwriting, by the way. So I have 3 scores below and 3 scores above. What I need to do then is find the number that is exactly halfway between 79 and 86. And to do that, what I want to do is just average together 79 and 86. So I can do 79 plus 86 and then divide by 2. And that will tell me exactly what's halfway between those 2 scores. That would give me a median of 82.5. If you have an odd number of scores in your list, usually the median score will be one of the scores in the list. But if not, then you're going to get a value that is not part of the scores in your list. Now, oftentimes when we're calculating a mean, because we're adding individual scores and we're dividing by the number of scores in our list, our result starts off as a fraction with a numerator and a denominator. So the numerator represents the sum of all the individual scores, and the denominator represents the number of scores added to get the sum. Depending on what type of situation we're looking at, the answer might make more sense to stay as a fraction, or it might make more sense to convert it to a decimal or as a percent. And in different types of sports situations in particular, sometimes we keep those values in one form or another. In example 7, we're going to take a look at a couple of those. And it says not only to calculate the mean in example 7, but to decide whether the mean would be most useful as a fraction, percent, or decimal, and then to express our final answer in that form. Letter A says the number of yards gained on each play in a running back's last football game are, and then we have a list of yards. Notice that some of those values are negative, and it's not uncommon in sports situations to get negative values. In this case, a negative would represent the running back losing yards on a play. So if we want to calculate the mean yards per play, just like we did in the past, we would add all of those values together and then divide by the number of plays that the running back has gained. And notice it says yards gained per play. That tells us that the number of yards would go in the numerator and the number of plays would go in the denominator. If I add all of those numbers together, 5 plus 8 plus 4, etc., including the negative, I would get 68 yards. That would represent the total number of yards that he gained. And there were a total of 15 plays in this list of numbers. So yards per play is set up correctly for the units they're asking us for. And 68 divided by 15 would be 4.5333 yards per play. Now, in this case, it doesn't make sense to turn that into a percent or a decimal. So we'll just leave it like that. In letter B, it says a NASCAR driver completed 20 laps in 4 minutes and 18 seconds. What is his average speed in seconds per lap? Notice the units they're asking us for, seconds per lap, which means when we set up our division, we're going to put the seconds on top and the laps on the bottom. Now, the time is given to us as 4 minutes and 18 seconds. So the first thing we need to do is convert that to seconds. And I know that there are 60 seconds in a minute. So if I take 4 and multiply it by 60, that would give me 240. And then I'm going to add the 18. And that will give me the total number of seconds that this driver is driving. And that works out to be 258 seconds. And now in that amount of time, the NASCAR driver completed 20 laps. So notice we have that set up seconds per lap. And when we divide, we get 12.9 seconds per lap. And again, it doesn't make sense to turn that into a percent. So we'll leave it just as it is as a decimal. Letter C, a golfer keeps track of whether her drives land in the fairway or not. Here we're recording 1 as being it lands in the fairway and 0, it does not. Calculate the mean number of drives that land in the fairway. So here we're going to basically consider each time the ball lands in the fairway as a success. And I count up all those ones. There are 11 of them. I could also add 1 plus 1 plus 0 plus 1, etc. Anyway, we get 11 successes. And the golfer had a total of 18 attempts at the fairway because there are 18 numbers in that list. So 11 successes out of 18 attempts gives us 0.611, and that is a decimal. Now, in this case, it might make sense to turn that into a percent. So if I move the decimal point to the right 2 places, that would give me 61.1%, and that would be what we consider drive accuracy for a golfer. Letter D is a good example of a common measure of average that we're going to calculate in this class, and that's batting average. The way we calculate batting averages is very similar to what we did in letter C, where we want to take the number of successes out of the total number of attempts. In baseball, a success is considered a hit, and an attempt is considered an at-bat. So in this case, the batting average would be 112 hits or 112 successes out of the number of attempts, which is the 425 at-bats. And 112 divided by 425 is the decimal 0.264. With batting averages, we will always round to 3 places, and we will always keep it as a decimal. We never express batting averages as a percent, even though with other types of sports like golf, we do express accuracy or like save percentages in both forms as a decimal or percent. Batting averages will always be decimals. All right, that concludes lesson 0.3. Please do the assignment in your worksheet packet from this lesson for tonight.